Hey guys, welcome back to factoring. This is factoring day 2. If you missed lesson 69, I need you to go back and watch the recording for 69. This is assuming that you already know how to factor trinomials. Today we're going to talk about factoring special products. It would be the difference of two squares. It's a certain pattern that we're looking for. Okay, so the difference of two square patterns, you're basically going to start out with a binomial, and I'll give you an example that's not there. Say I had something like 4x squared minus 16. Okay, this is a binomial, but if you look at it, the first term, 4x squared, is actually a perfect square because we can take the square root of it and get 2x. Okay, so if I took 2x times 2x, I would get 4x squared. Now, because it's subtraction, or the difference of perfect squares, and 16 is also a perfect square, I can simply factor 4x squared minus 16 to be 2x plus 4, and then 2x minus 4. Okay, so if you notice, if I FOILed it, 2x times 2x is 4x squared. My outer would be negative 8x. My inner would be positive 8x. So that causes the middle term to cancel out. And then we have our last term, 4 times negative 4, which would be our negative 16. So in the two examples that we have, a squared minus b squared, we can take a times a and get a squared. And it is difference. So then it's b squared, which is b times negative b. So let's look at some examples here. So if I look at 100x squared minus y squared, now keep in mind you're always going to factor out the greatest common factor first. Okay, in this case we don't have any. So we're going to start out and say, well, 100x squared, the square root of 100x squared is 10x. And then we've got 10x. So 10x times 10x is 100x squared. And then for our y, it would be plus y minus y. Okay, and you can also do minus y plus y because remember, multiplication is commutative. The order doesn't matter. Okay, if I look at number 2, again, the first term, y squared, is a perfect square. So y times y is y squared. And 16 is a perfect square, and it is the difference. So it's plus 4 and minus 4. Again, if I FOILed it, I would get y squared minus 4y plus 4y, so your middle term cancels out, and then minus 16. Okay, n to the fourth would be n squared times n squared is n to the fourth, and 100 we can say plus 10 and minus 10. Okay, now number 4, we want to start and we want to first factor out the greatest common factor. So if I looked at 16 and 36, I can factor out a 4. And let's see, can I do anything with the variables? Nope, just a 4. So this would be 4p squared minus 9y squared. Now looking at what's left in the parentheses, they're both perfect squares. So it's the difference of perfect square pattern. So I can actually write this out as fully factored 2p times 2p and then plus 3y and minus 3y. Okay, so this binomial actually has 3 factors. Okay, 4, 2p plus 3y, and then 2p minus 3y. Okay, if I looked at number 5 has a greatest common factor. It would actually be 16. So 16 times 25 minus 16b squared. Okay, now again, I have difference of perfect squares. So 25 is a perfect square. We can say 5 and 5, and then plus 4v and minus 4v. Okay, for number 6, we've got a perfect square here, 81x squared. So we've got 81, so we've got 9x, and 9x gives us 81x squared. And 169, the square root is actually 13. So we're going to say plus 13y squared and minus 13y squared. Okay, and we didn't have any greatest common factors for that. Okay, number 7, if I factor out for number 7, I've got, let's see, we can factor out a, okay, I can actually factor out a 16. So if I factor out a 16, I've got 16 times, it would be 9s squared minus 16y squared. And again, what's left in parentheses are both perfect squares, so I can continue factoring. Difference of perfect squares, so I've got 3s and 3s, then plus 4y, and then minus 4y. So now we're fully factored. Okay, for number 8, 81 and 900, let's start out and factor out a 9. Okay, and actually we can factor out a 9v squared because if you notice we've got v squared as a common denominator, so 9v squared, and we're left with 9v squared minus 100. And what's left in parentheses are both perfect squares, so let's factor those into 3v, 3v, and then plus 10 and minus 10. Okay, 9, we'll start out and factor out a 2, so we get 16 minus g squared. Again, what's left in parentheses are both perfect squares, difference of perfect squares, so we've got 4, 4, and we've got plus or minus, and we're going to say g. So 2 times 4 plus g times 4 minus g. All right, and number 10, if we factor out a 2, we've got 49n squared minus 100. Now they're both perfect squares. It's a difference of perfect squares, so it's 2 times 7n. Times 7n is 49n squared, and we've got plus 10 and minus 10. All right, number 11, they're both perfect squares, so we've got an r plus 1 and minus 1. Again, it only works when it's subtraction, so the difference of perfect squares. Okay, we're looking for this pattern. Okay, r squared and 121, again, both perfect squares. If you're not sure, just take the square root of 121, and if you get a whole number, it is a perfect square. So we've got r and r plus 11 and minus 11. Okay, 81a squared and negative 4, so we've got 9. 81 is a perfect square, so 9a, and then we've got plus 2 minus 2. Okay, for number 14, we want to factor out the leading negative, and when we do that, we have, actually we're going to factor out a negative w as the greatest common factor, and we end up with w squared plus 40. Okay, now, oops, it's not w, it's minus 40, sorry. So that's minus 40, and 40 is not a perfect square, so actually it's not a very good example, but we're going to just stop right there, so it's just w squared, and then it's minus 40. Okay, so that would be our final answer. Okay, so again, 14 wasn't a very good example. Okay, so the second part that we're going to talk about today is dividing a trinomial by a binomial. Okay, what I want you to do is you don't want to just start dividing. You're not going to take x squared and divide by x. You're dividing the whole trinomial by x minus 10. So in order to do that, you need to first factor the numerator, okay, and the denominator in case if they're both trinomials, and then find any common binomials in both the numerator and denominator. So what I mean by that, if I look at number 5, if I factored it, okay, and I'll use my x to factor, and you can just factor, guess and check if you'd like. But we've got x squared minus 2x minus 80, so I've got a negative 80 up here and a negative 2. And I can say, well, what two numbers can I multiply to get negative 80 that add up to negative 2? And I'm going to have a negative 10, and I'm going to have a negative 10 and 8. Okay, so if I did that, and then I divide by the leading coefficient, which is 1. So when I factor the numerator, I end up with x minus 10 times x plus 8. And since I'm dividing it by x minus 10, in this case, the x minus 10s cancel out, and my answer is just x plus 8. Okay, so if I looked at number 16 and I factored it, okay, I've got negative 45. And I've got a 4. Okay, so what two numbers can I multiply to get, I can get a 9 and a 5 to get 45, and it's going to be negative 45, and I want it to add up to 4, so it's 9 and negative 5. And I divide by my leading coefficient, which is 1. So I end up with x plus 9 times x minus 5, and I'm dividing it by x plus 9. Okay, so in this case, the 9's cancel, x plus 9's cancel out, and my answer is x minus 5. Okay, at this point in algebra, what's typically going to happen is one of the factors in the numerator will cancel out. So you can kind of look at the denominator and then figure out what the numerator factors are. Okay, so if I looked at number 17, I can factor it. I'm not going to get into the x, but I can factor it as x minus 8 and x plus 4. Okay, and I'm dividing it by x minus 8. So I cancel those out, and my answer is x plus 4. So if you want to pause the video and try some of these and then check your answer, that would be great. Okay, number 18, if I look at it, it is a binomial, but it's a difference of perfect squares. So I can factor the numerator as x minus 6 times x plus 6, and then I divide by x minus 6, so they would cancel out. My answer would be x plus 6. Okay, number 19, if I factor out a 3 for starters, because the greatest common factor is 3, and I'm left with x squared plus 7x plus 6 divided by x plus 1. I then can take that trinomial and factor it into two binomials by doing the x if I need to. I'll show you again here. 6 and 7. I could say 1 and 6, divide by the 1. Okay, so I've got x plus 1, and then I've got x plus 6. Okay, and since we're dividing by x plus 1, we can cancel out those x plus 1. So my answer is actually 3 times x plus 6. Okay, 20, I'm going to first start out by factoring out a 4. Okay, and then I'm going to factor, and we're dividing by x minus 9, so I'm going to further factor that. It's going to be 4 times x minus 9 times x minus 4, and then I divide by my x minus 9, so again I cancel out. My final answer would be what's left, which is 4 times x minus 4. Okay. All right, 21, you would factor the numerator into x minus 8, and then 3x minus 8, and then we divide by x minus 8, and we're left with 3x minus 8. Okay, and then number 22 can factor into x minus 6 and 3x minus 2. Again, we're dividing by x minus 6, so we're left with 3x minus 2. Okay, and then for 23, let's do the x in this one just so that you can see. So we're going to start out, and we get a pretty big number. We get 108, and then we have a negative 56. So we can actually take a negative 54 times negative 2 to get 108. We divide by the leading coefficient, okay, which gives us a negative 6. So when we factor it, it's x minus 6 times, don't forget this denominator becomes a coefficient, so 9x minus 2. Then we divide by our x minus 6. These would cancel out, and our answer is 9x minus 2. And then the final one, if we factor the numerator, we're going to be left with, we're actually going to factor out an x first. So we get x times 6x squared minus 7x plus 1 divided by x minus 1. Now I factor the trinomial, and I get x times x minus 1 times 6x minus 1, and then I divide by x minus 1. And the x minus 1's cancel out, with my final answer being x times 6x minus 1. Okay?